Okay everyone, so I'm going to talk about the database, one topic of the database system courses, which is normalizations. Normalizations is a bottom-up techniques to create sets of relations. I would like to explain about the process, how we start from gathering the user requirement specifications. So from the users, we can do some interviews, or we can also collect the forms or reports that are used or generated by the enterprise. And then we can also get the sources describing the enterprise, such as data dictionary and corporate data model. And then from these three sources, we can build user requirement specifications. So this is how our data sources. From here, we can also do the top-down approach, such as ER modeling. But now, today, we're going to talk about the normalizations to design our relations. As an example, this is a business process about the property inspections by staff. So this is the staff. The staff has a staff number and staff name. At a specific time and date, they were assigned to use the specific car using a registered plate number to go to the property to do the inspections. The property itself has the property number and property address. And then the staff that doing the inspections can create a comments about the properties, whether the properties need to be fixed or anything that they already seen in the properties. Okay, and this is our ER diagram for property inspection by staff. We have entity staff with staff number and staff name, and then we have property entities with property number and property address. And then both of the entities related through the inspect activity. The inspect activity itself has the attributes like time and date, car register plate number, and comments. This relationship is many-to-many, which means staff can inspect one or zero or many properties, and one properties can be inspected by at least one or more than one staff. Okay, let's start the normalizations. In the normalizations, for example, we do have unnormalized table looks like this. The property number PG4, the information that we need for this property number in this address, at this address, 6 Lawrence Street, Glasgow, is 3 different sets of record. Yeah, so for example, they've been inspected by 2 different staff and at 3 different dates and time. Yeah, so these 2 staff, Anne Beach and David Ford, has inspected the property number PG4 at different dates, 18 October, 22nd April, and 1st of October. And they also write down the comments for each inspections. Okay, the problem here is we still have a repeating group. Okay, so this is our goal. In the first NF, second NF, and 3 NF, and we're going to make our BCNF, and this is our goal. How do we build this? Okay, so this is the first normalization form. In the first normalization form, we need to remove repeating group. From the first table, our unnormalized table, from the first not from our first unnormalized table, something like this, PG4 has 3 records because the PG4 property number PG4 has been inspected 3 times and property number PG16 has been inspected 2 times. So in the first normalization table, we need to get rid of this kind of problem. The table displays data redundancy. First, update anomalies. If we try to update staff name, we need to do more than once. So for example, we need to try to update David Ford into David Ford Campbell. For example, we need to do it like 3 times. And also, the other problem is addition anomalies. If we try to add new staff and that staff hasn't been assigned to inspect any other properties, there will be a problem. And then the third problem is deletion anomalies. This happens when we try to delete one staff from the table. For example, we want to delete and beach, and then all the record will be gone, including the property number record. Okay, how do we solve this problem? The answer is first normalizations. Okay, and in the first normalization, we need to identify the keys and remove repeating groups. So from this unnormalized table, we have first normal form, something like this. So every single row now is unique. We don't have repeating group anymore. Okay, so what happened next? After first normalization form, we jump into second normalization form, 2NF, second normal form. What we need to do here is remove partial dependency. What we need to do in the second normal form is remove partial dependencies. Okay, I show you again. This is our first normal form table, where every single row is unique. There is no repeating groups anymore. To do the second normal form, we need to know what is functional dependency. Functional dependency is typically between the primary key and other non-key attributes. The relation, the dependency between the primary key and other non-key attributes. For example, this is just examples. When we see the column A, we see all the values in the column A where is come up with Z in column C. In the second row, E come up with R in the column C, and then A come up with Z again. So we can say in our functional dependency 1, column A is functional dependent to column C, and then the other way around, because they always come together. Yeah. Okay, so how about the B and D? We call this also functional dependency. B, when the value in the column B is B, the value in the column D is always W. B, W, B, W. And then what happened when the value in the column B is D? Oh, okay, in the column D, they always have the same value again, W. D always determine the value of the column D, which is W. D always come up with the value in the column D, which is W again. It doesn't matter where the attribute where the value in the column D, this one W, for the key B, this is W, for the key D is also W. The most thing that matter is when the key come up, then the non-key attributes always come up with the same values. Okay. There are also something like this where the key consists of two columns. For example, in a functional dependency for A and B together determine the value of column E. Okay, that's the concept of functional dependency. So this is the process how we do second normalizations. After we know what is the functional dependency in your table, in our table, and then we decided which one is partial, which one is intransitive. Partial dependency means something like this. If we know that these two, property number and IDate, inspection date, is the primary key of the whole table, they decided when they together, they decided the value of the other attributes. For example, if we know the property number and inspection date, we also know the inspection time, comments, staff number, staff name, and car register number. Okay, so what is partial dependency? Partial dependency is a type of dependency where the key here is part of the primary keys. Okay, but the key itself is not together with the other key. So for example, property number on its own determine the value of attribute property address. So we can call this partial dependency. Okay, what do we need to do in second NF is remove partial dependency. It's still easy, yeah? Okay, so from the master table, staff property inspections, we remove the property address, so we build another new table here, which called properties. Consists of property number and property address. Okay, and we leave the table details as it is, like this: property number, inspection date, inspection time, comment, staff number, staff name, and car register. Okay, this is our second normal form. Now the third normal form is when we remove the transitive dependency. According to the functional dependency, staff number is a transitive dependency. So how do we remove this? We create another table here which call staff table. Staff table has an attribute staff number, which is the primary key of the relation staff, and it also has the staff name as a non-attribute, non-key attribute, as its non-key attributes. Okay, and then how about the next step? There is a concept called Boy's Code normal form B, C, and F. It is an advanced version of 3 and F. A relation is in B, C, and F if every determinant of a relation is a candidate key. Okay, this is just an example. For example, from here, functional dependency 4, functional dependency 5, functional dependency 6, this all reflect the candidate key. From 3 and F, we do have something like this: property, staff, and property inspect. The first and second relations already satisfy BCNF. Property only has property number as the primary key. Staff only has staff number as the primary key. But how about the property inspect? From the property inspect, we do still have functional dependency 1, 4, 5, and 6. In a BCNF, they don't allow something like this. A car register, if we see the functional dependency for staff number and inspection date, determine the value of car registers. If we see in the table, staff number is not a primary key of the table property inspect. This is not allowed in the BCNF, but this is okay for 3NF. So we need to separate another table from this property inspect. For example, because according to BCNF, we still suffer from this problem. For example, to change the car allocated to staff number SG14 on the 22nd of April 2012, we must update two tuples. Yeah, like this. So this is the difference between 3NF and BCNF. A functional dependency A to B, 3NF allows this dependency if A is not a candidate key, but in BCNF, it insists that for this dependency, A must be a candidate key. Every relation in BCNF is also in 3NF. However, a relation in 3NF is not necessarily in BCNF. So from 3NF to BCNF, we do something like this. We separate the car register and staff number with inspection date as a separate relation, separate table, which we call staff car. Staff car has three attributes: staff number, inspection date, and car register. And we keep the master table as it is. Inspections consist of property number, inspection date, inspection time, comments, and staff number. And then we already has BCNF, which consists of four relations: staff, staff car, inspection, and properties. So this is our goal.